friends. I am back. I am back. I am back. All right. So now when we're dealing with the problems, there's two parts we need to keep in mind. The word, one part, and then solving those. So like when we go to solve these, we just do the solving like we would normally do. Divide by 5, divide by 5. X is less than, don't do any flipping there. We get that, but then we write the word in between down at the bottom. Then we keep going. Add 5, 2x greater than 8, divide by 2. And we get x is greater than 4. Okay, so now we turn around. It's an or, okay, which is the u. It is an or, and we go to graph these two parts separate. So we're going to look at that, and we're going to read that. We want x is less than or equal to less than -4. So we're going to drop -4, and that's an open circle because it's less than, and we want the shaded to be less than -4. So we're going to drop that there. So then the next part, here, x is greater than 4. We're going to drop 4 to the right. Okay. So again, it's an or. So we take all of the parts of both of them. Or means you take the intersection between them and all of the separate parts that don't overlap. So you just kind of graph the two parts in there, and you just kind of look at the picture and try to simplify it from there. And then if we write the interval, we write the interval for this one. It's easier to write the intervals from the graphs. Okay, there we go. And then we get the union symbol, which is a U, meaning all of the parts, meaning an or. And then we have this part on the right, x, ooh, we're writing the interval, parenthesis 4, comma, infinity. So that's the interval. This would be the solutions as an inequality. Let's keep going. I'm going to use colors a little bit better. So we're going to -6, so we get negative x greater than 9er. Divide by -1, divide by -1, we get x is flipper. Flip it, flip it, flip it, flip it, flip it. Drop the or down to the next side. 6x minus 14 greater than or equal to 10. Keep it going. 6x greater than or equal to 24. Divide by 6. X is greater than 4. Okay. So now we have these two that are working together because it was a single statement with it. Or, so we're going to graph them on the picture. -9. This is the graph of the red one. Open circle. It says x is less than. So we get that. The green one is greater than or equal to 4. So we get that one. Okay. So now it's an or. So we just leave it. We're done. We're good. We're good. When we draw the interval, ooh, -infinity. That's an 8, not an infinity. Silly Showalter. -9, parenthesis, union. And then the other side, 4, bracket, because it's shaded in, and that would be our interval. Here we go. Divide by 3, divide by 3, next one. We get x is less than 4, drop the or. -3. There is no flipping here, so that's nice. We got that going for us, which is nice. So let's turn around and graph this. X is, ooh, that looks like I put an underline there. So this one, x is less than 4. We're going to graph this open circle. It's going to go that way. X is greater than or equal to 2. Okay. Ooh. Okay, so this is a situation now where we have an or, but they're overlapping. Okay, since they're overlapping and they're pointing opposite ways and they're overlapping, it's actually a situation where we want to fill in the whole number line. And our final answer to this, because we want the or means like you take the overlap and all of the other parts from each of the two separate inequalities. So we end up filling in the whole number line, which if we do that, remember it's -infinity to infinity to express it, and it's all real numbers, saying that any number under the sun makes a true statement in that expression up above. Okay, here we go. Next Now, there's another type of scenario. This one's a weird one, by the way. Did I spell weird right? I don't even. Anyways, now we have a situation where we have ands. Now, ands are just where the two overlap. So, like, if we go ahead and we solve this problem, we go ahead and solve this problem. We graph those two separately, which represents this one is represented by that one. This one is represented by that one. But since we have the word and in the middle, we end up changing the way we go about it. We have to change the way we go about it because it's an and we have to reflect of what the and means. If you read this, it means like that it's the overlap. It's where both of the inequalities are true. So if we were to slide these two pieces together, see if I can do this expeditiously. That means fast. If we were to take these two and we were to highlight them and move them together, we only want the overlap between the two. So we chop this off, and we just want that. Reason is because of that word and what that and actually means in the problem itself. Okay, so we have to interpret what these mean rather than just create like memorizing rules to figure out what they actually. Things that you need to memorize is that and means it's just where they overlap, different than or means where they overlap and or like all over the place, where they're pointing on their own or when they cross. Okay, we highlighted that in this your problem. No, that got a little weird. But on this, it's when they just overlap. Okay, because of the word and. So when we're dealing with these problems, so let's go -7, 3x greater than -3, divide by 3. X is greater than -1. Over here, -5 is less than 4. Okay, and when we write it, we drop the word and in between because we have the word and, graph them separate, and then do some erasing. So here we go. We have this one graphed up, the green one, open circle to the left. Okay, and then the red one, -1, open circle to the right. We are only going to keep the parts of it that overlap. So these go away, this goes away, and inside that circle goes away, and we get an open circle there. So our final answer is an open circle because the red one just went that way, and we're only taking an open circle, and we're only taking what overlaps between the two. Okay, so our final answer is this. When we turn around and write the interval for it, it would be -1 to 4, both parentheses, because they were both open circles over here. There's another way to write the inequality. We could say that x ends up being squeezed between those two numbers. Okay, that's another version of these and problems. And you're going to see a situation where they're down there in a bit. Okay, so we're going to turn around, do it again. Distribute n minus 2x greater than 8, and no, we're going to skip this one. We're going to just go to the next one. -5 minus 5, we get 2x less than or equal to 2. Divide by 2, divide by 2. So again, what are we doing? We're solving them separately because they're separate problems. They're written as two separate statements, but together with the conjunction there. X is greater than 3. We're going to graph them. So again, this number 1 here, we got a 1 there. X less than or equal to, so we're going to fill it in and go that way. This one says x is greater than 3, so we're going to go that way. Now the situation happens where it's a little funky too, because they no longer overlap and we have an and scenario there. So we actually don't want any of the graphics if they don't overlap. Remember up here, we want to keep just where they overlap if the word is and. Again, there's a expression, a description of what is going on up there as to why. We only take the overlap. So right now we have no solution because they don't overlap. Okay, and our interval, if we write our interval, be 0 to 0. Okay, there's one more scenario that we need to pay attention to, and I'll get that on a part 3 video. Peace.